Welcome to Session 17, Slope and Linear Equation Forms. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to calculate slope with consistent subtraction order, to move among slope-intercept, point-slope, and standard forms, and to write parallel and perpendicular line equations. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Positive, negative, zero, and undefined slopes are identified by direction. Read each line from left to right. Rising means positive, falling means negative, horizontal means zero, and vertical means undefined because its horizontal change is zero. The key distinction is this. Calculate slope with consistent subtraction order. Then connect it to the second goal. Move among slope-intercept, point-slope, and standard forms. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Use the same point order in both slope differences. Identify the object being changed and the requested result. Step 2. Choose the line form matching the supplied information. Use a separate line so signs, units, and restrictions stay visible. Step 3. For perpendicular lines, use the negative reciprocal slope. Work efficiently without skipping an operation. Step 4. Substitute the known point into the finished equation. Whenever possible, verify with evidence independent of the original working. Signal 1 is 1 point and a slope. Respond by remembering use point minus slope form. Name the response before calculating. Signal 2 is parallel line. In that case, keep the same slope. The form tells you which tool fits. Signal 3 is perpendicular line. Remember, use the negative reciprocal slope. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here's our challenge. Find the line through 4, 1, perpendicular to y equals 2x plus 5. Restate the target and identify the most important part of the routine. The first move is, the given slope is minus 2, so the perpendicular slope is half. This changes the form without changing the meaning. Next, use point minus slope form, y minus 1 equals 12 minus 4. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Distribute y minus 1 equals 12x minus 2. State what the transformed line tells you. Complete the argument. Add 1. Y equals 12x minus 1. The point, 4, 1, satisfies it. This is part of the solution, not decoration. The final answer is y equals 12x minus 1. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. What slope is perpendicular to 3/4? Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. Focused hint. Take the reciprocal and reverse the sign. Use it to repair your setup rather than guess. An accepted answer is 4/3. Explain why it works and name the first step that would expose a common error. The central message is, calculate slope with consistent subtraction order. Combine it with the discipline to move among slope-intercept, point-slope, and standard forms. Finish by remembering to write parallel and perpendicular line equations. This turns a calculated result into a justified answer. Reflection. Why is the slope of a vertical line undefined rather than zero? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes, including point verification. Keep the work readable, check it independently, and carry the routine forward.